Hello, friends, and welcome back. And today we are going to discuss one of the earliest modeling technique in AI, which is known as the rule-based AI modeling. So there are various AI modeling techniques, and one of those which was very earlier one is the rule-based AI modeling. So what is the rule-based AI modeling? If you see here, the simple definition has been given here. I am just highlighting it. So the rule-based approach to AI modeling is one of the earliest and most straightforward methods in artificial intelligence. It operates on a predefined sets of if-then statements known as rules to process input data, and make decisions or draw conclusions. Essentially, human expert in a specific domain translate their knowledge into these explicit rules which the AI system then follows. It's very simple to understand. There is nothing like a rocket science to understand this. So there are certain human experts. So basically, those human experts know that if I want to automate these processes without interfering or without interacting with the humans, if I want to create a system or a bot which can, give the answers like a human, then in that case, we can create a rule-based AI model which will be acting like a person only to whom some question has been asked, right? But those questions are really static. Those questions cannot be changed. Only those questions which have been fed by the developers of these kind of expert system, only those questions can be answered, not apart from that, nothing else apart from that. So imagine it's a sophisticated flowchart where every decision point is a rule. This is the crucial thing. It's a sophisticated flowchart where every decision point is a rule. When the system receives input, it compares that input against its sets of rules. If condition specified in a rule is met, the corresponding action is executed. Right. So suppose there are a number of examples that we have given below, so that we are going to understand very soon. So we can till then we can understand what else has been mentioned here. So if a condition specified in a rule is met, the corresponding action is executed. This process is deterministic, meaning that for the same input, the system will always produce the same output, making it highly predictable and transparent, right? For example, in our case, if you have used the AI, you might have seen that every time it will give a different answer, right? The essence will be same, but the thing is the selection of the words could be different, right? Not the same set of words or not the same set of uh, you know options it could have used to explain the things, right? But the thing is that in case of an expert system, the questions are there and the answers have been fed already. So all those answers which have been fed into a bot for a bot, only those answers every time will be responded. Every time it will give you the same response. But in case of AI, modern techniques of the AI, modeling techniques of the AI, which are not rule based, modern techniques of AIs, they are not rule based, right? So all those are giving different answers. You can play around with it. There is no saved answers, just like in case of rule based modeling approach that we are discussing right now, right? So in case of rule based techniques, the answers are always fed beforehand, and only those answers will come every time. Okay, now come to the next thing, key components of a rule based system. What are the key components? So first is knowledge base. This is where all the rules and facts are stored. Rules are often in the form of if then, you know if this is the condition, or if this question has been asked, or something like this has been asked, then I will give this kind of answer, I will take this action. Then comes the inference engine. This is the brain of the system. Inference engine, it applies the rule from the knowledge base to the given input data, comparing conditions and executing actions. So basically this is the decision maker part. Working memory, this is just like the main memory, where you hold the specific data or facts that the system is currently processing. Then comes the user interface. User interface is where you will help the user to visualize the answer, right? Allows user to input data and view the system's output or recommendations, where the user can interact with the system, with the bot. That is what is done through the user interface. So in case of rule based AI modeling, it's simply like something like a bot, which you already know about the bots. They are nothing but the rule based AI models, right? I hope that makes it clear. Now come to the some of the examples of rule based modeling. One is medical diagnosis system. So here it has been written like, if a patient has fever and cough and sore throat, then suggest flu diagnosis. So every time if some person puts some question, and in that question, if something like fever, cough, or cold or sore throat has been mentioned, then in that case the inference engine, this second interface, the second component, this will find out like which answer I need to give, where I need to go to find the answer, how to decide that which answer I need to give. That all is decided based on this one, based on then. So based on then, before it comes to the then, if it decides what is the user asking for. So that's all the work of inference engine, and then it gives you the output. Okay. So if flu diagnosis and patient has difficulty breathing, then recommend consult doctor for severe condition. So these are the two different if conditions for a medical diagnosis system, which can be an expert system which it is acting like a bot, right? Which is acting like a kind of expert doctor. Although it's not a doctor, it's a machine. It's a kind of program. Then also it has some predefined set of rules, and based on those rules, we are giving the answers, right? So before the AI, the bots were really, important. Bots were really fascinating for all of us. But now we all know what is the story. Okay, so when a patient's symptoms are entered, the system can then use these rules to suggest possible diagnosis or recommend further actions, streamlining the initial assessment process. Now come to the customer service chatbot. This is again the another example. You can stop the video for a while. You can read it, but I think there is nothing to explain here. Similarly, you can stop the video for fraud detection system if you want to read it, and you can understand like what it has been written. Like this is all very simple. If you have developed any bot, then you know all these things that how these are working. Okay. Now come to the last part of today's video, which is the limitations of the rule-based modeling. We all know that there are limitations, but let us just combine all of them and consolidate them. So first is lack of adaptability and flexibility. Why? Rule based systems are static, they can only act on what has been explicitly programmed. If a situation arises where arises that isn't covered by an existing rule, the system fails to respond or provides an inaccurate one. They cannot learn from new data or adapt to evolving conditions without manual intervention. You know, they cannot learn it themselves, just like the machine learning models do or the AI models do. So these are different from the current AI models that we are working on. These expert systems, these rule based AI models, they cannot learn themselves. If you want it to improve, then you need to program it further. You need to decide new set of rules and corresponding actions, and then only it will start working as per your needs. Then comes the scalability issue. As the complexity of the problem domain increases, the number of rules required can grow exponentially. Managing a large rule base becomes incredibly complex, leading to difficulties in maintaining consistency, avoiding conflicts between rules, and ensuring accuracy. Adding new rules can inadvertently break existing logic. Now come the difficulty with ambiguity and nuance. Real world problems often involve ambiguous or uncertain information, human emotions, or subtle patterns. Rule based system struggles to handle such nuances because they require clear cut, definitive conditions. They lack the ability to infer or generalize like humans or more advanced AI models like machine learning, right? The other one is knowledge acquisition bottleneck. You can easily understand why this has been written. Now comes to the next one, limited learning capability. Unlike machine learning models, rule-based system do not learn from experience because this is not machine learning model. This is just the set of rules already written, hard coded, and the responses also hard coded. The actions also hard coded. All those things are already there. Nothing apart from that it can mention or it can respond. Comes the maintenance overhead. With a large and evolving set of rules, maintaining the system becomes a significant challenge. Any change in the domain knowledge requires corresponding update to the rules, which can be costly and prone to errors. Due to these limitations, rule based models is often best suited for specific, well defined problems with clear and stable rules where transparency and predictability are paramount. For problems involving large data sets, dynamic environment, or complex pattern recognitions, other AI approaches like machine learning are generally more effective. Modern AI systems often combine rule based components with machine learning to leverage the strength of both. Okay, so I hope you must have understood that what is the limitation and where still the rule based AI models are useful. So it's not like they are obsolete. It's like you need to understand what is your requirement. You need to understand what kind of system, what kind of expert system you want to build. It something which is not evolving? Is it something which is very much a stable product now, and about that product you want to give some information to the user, the bot can help there? Then in that case you can use it, right? So there is a lot of work to do in case a system is really big and you want to create a rule based AI model. So I hope you must have enjoyed the video. In the next video we will meet soon. Till then, have a nice day and bye bye. Thank you.